Hi, I just assembled my JTAG, my second JTAG, this year's JTAG, and I figured that it would be nice to do a little tutorial on how to program it. I haven't powered this at all. I just finished soldering, so we're going to use my old JTAG to program the new JTAG, so you can repeat the procedure to use your own to give life to your friend's JTAG, because basically the design is the same. The PCBs are a little bit different, but essentially are the same and they work in the same way. So software-wise, what I will do with my JTAG will be exactly the same as what you will need to do to program your friend's JTAG, and it's also the same thing you need to do to program your own game console when you have your binary file, your final binary file. So we are going to first start by testing, because you don't want to connect your just assembled JTAG to the computer without doing any testing, because you don't want to burn anyone's USB port. And for that, we are going to use a multimeter. Whoop. Continuity mode. And the very first test is to ensure that we don't have shorts between ground and VCC. In this case, 5 volts is there, and you can see that the LED is turned on, but we don't have continuity, and apparently there are no shorts, so that is good. One thing to inspect visually is the orientation of the chips. You want to make sure that the pin 1 of the FTDI chip is aligned with this little dot here, and the pin 1 of the MCU is oriented in this way. This little corner here is the pin 1 mark. So I just checked with the multimeter, there are no shorts, so we shouldn't be burning anything. So the way this works is that for the first time you program your JTAG, you don't connect it to anything else but the other JTAG. So in order to do that, I'm using a spare pin header, the one that you put in your game console. So what I'm going to do here is to just plug it here in the right orientation, of course. Yep. And then we're going to use this pin to the first program. So the whole point is, this microcontroller is the one that understands JTAG language, let's put it that way, and this talks to the computer using this FTDI chip, which translates the protocol to USB. So in order to make this work as a JTAG, we have to put on this microcontroller the right software to do so. And that software is on LMS. You can download it and follow the steps in there. And I'm going to do it now, so you can follow this video for that. The first thing is having the cable connected in this way. Check the pin 1 markings in both PCBs. By the way, the orientation of the pins are exactly the same in both boards, so it doesn't matter if you just follow it. Don't care that this one is slightly different. And here, I don't know if you can see this in camera, but this connector here has a little arrow there, and there is the pin 1 mark in that specific point. So you want to align this pin with the square pin in your new JTAG there. So we connect it like that, and this is a little trick. If you just put it there and you don't solder anything, you're not very sure if you're making a good contact. So in order to make sure that you are having a good contact with all the pins, you can put it like this and push it a little bit with your finger like that. So that way you incline a little bit the connector, and you make sure that all the pins are connected to the holes, the pads in the holes in the new JTAG PCB. So it's a little bit annoying the first time, because you will be holding the JTAG like this the entire time you are doing the programming, but it's not that bad, and once you get used to that, it doesn't take too long. The other thing is the power. So These JTAGs have a little pin. In the case of this one, the pin for delivering USB power to the microcontroller is this one, and in this case is this one. So let's imagine that this is ready to program a new one. What you want to do is to provide power from the USB to the microcontroller, and then using the JTAG to the other JTAG. This is only used for the first programming of the JTAG, because the USB delivers 5 volts and your game console works with 3.3, and you probably don't want to force 5 volt here because it might conflict with possibly your FRAM or some other chip in there. So that's why we have this header here, which cuts the 5 volt trace from the USB, and this is the power line for the microcontroller. So for the first time programming, what you want to do is to place a little conductor or whatever. I soldered a header and I'm using a proper jumper there, but you can use just a wire if it is just one time thing. You bridge this, so you power the microcontroller with your USB, and then this power gets transferred to this connector, and you can power the other device using the JTAG connector. So that is how you connect that one. I'm going to do the same with mine old one, and this equivalent pin in the old one is here, so I'm doing that. So now with this pin header there, my USB will power the microcontroller, and the power from the microcontroller will go through this cable to the other JTAG using this connector. And this is the wrong orientation. Make sure you have the right orientation all the time. Now, this connector here is directly connected to the VCC line of the microcontroller, so you don't have to connect anything here, and you don't have to connect USB or anything either. So the USB goes to the JTAG that is working to the computer, and then just the JTAG connector to this one, right? So I'm going to do that. Going to connect the USB. To unplug that just in case. And this is one of the quirks that I wanted to mention, because I've seen this in other people's JTAGs during this week. You have a little LED here, the prog LED, which is this one here next to the crystal. This indicates that your microcontroller is ready to work as JTAG, and this doesn't always turn on when you just plug the USB. Mine is like particularly dodgy, and I have to like try to power it off and on again a couple of times before I get this LED to turn on. This is important because if this LED is not on, then AVR Studio won't recognize the JTAG and you won't be able to program anything. So if you connect everything, you make sure that your connections are correct, you don't have shorts and everything is fine, but you still cannot connect to your JTAG, make sure that it is turning on this LED before trying, right? Now, I'm going to connect this in this way. Again, the little arrow, and be careful with this, please. This little arrow, the pin 1 mark there, goes to the square, but in there that also has a number 1. So now I can connect both like that, and then I just hold it with my finger like that, and go to the AVR Studio to do the programming thing. So we're going to do that now. Okay, so in your computer, the first thing you want to do is to check which serial port is the one that belongs to the JTAG you are connecting. Of course, the JTAG that is working. So for that, we're going to go to the device manager, check COM and LPT ports, and I have just one, so it is COM2. That is the port for my old JTAG. So now we can launch AVR Studio. We can cancel here, and we try to connect. So as I've done this before, the options are already selected. Note that at this moment I'm holding the board in the way that I showed, like pushing a little bit the connector, so we make sure that that is making contact. Platform, we have to select JTAG ISE, and then we select the proper COM port. You can use auto if you want. The baud rate remains the same, and then I just connect. Wait a little bit and we get this dialog here. If you go to fuses, you might get well, you should get the reading of the fuses. This is being read from the microcontroller I just installed, so this is a little big victory, which means that the microcontroller I just soldered is alive. However, you might get an error here, which is what happened to me the first time, which happened because I didn't have ATmega16 selected here. So if you go here, connect to the JTAG, click in there, and you get to see this window here, but when going to the fuses tab you get an error, you might want to try to come to main, click in here and select ATmega16 and then read signature. And then you should be able to read the fuses. Okay, as I said before, this one hasn't been touched, so this is the default state that you should encounter. You have to click on this bit here, and select in this drop down this selection here, which is basically setting my crystal. Right? So once we do that, we click on program and it's done. Fuses are set. So now we can go to actually load the software. So the software has two parts. One is the boot part, which writes one section of the memory of the microcontroller, and the other is the actual program that writes in a different part of the memory. So we have to start by the boot one, which is this file. Again, you download these files on LMS. You find them in the section documents. You click on documents and you scroll down, and you have these avrboot.x and avrcode.x. These ones are to make your JTAG to work. You have the fuses, the ones I just showed, in screen captures here as well, if you want. Okay, so we take avrboot. Double click, we make sure we are erasing the device for the first time with program. It is reading and is done. Now for the second one, we go and select code, but this time we don't want to erase the device because we don't want to delete what we just programmed. And now we hit program again, and this takes a little bit more time. You should see in the working JTAG the LEDs flashing for a while. It's doing it, waiting, and done. Okay, so now we're done, and it is ready. So now the JTAG, the second JTAG, should be working, but I'm going to make sure that that is the case. So what I'm doing now is to unplug the USB from the JTAG that was working before, and I'm going to plug in my new JTAG to see if this works. And remember that if you don't connect anything to the power pin, the one that shorts the 5 volts with the VCC, the ATmega16 won't get any power if you don't connect it to something else. So I'm going to put the jumper in there to make sure that it has power, and you cannot see it, but the LED is on, the one that I said that sometimes turned on and sometimes took like some attempts. Now it's fully on. So I'm going to test if I get connection, but now I have to check in my device manager what COM port is this new JTAG. So it is COM14, And unfortunately, we don't have COM14 here. So to solve that, we go to the device manager, we double click there, go to port settings, advanced, and we change the COM number. It's annoying that sometimes you have like all of them in use. I have changed this one to COM4 many times, like other JTAGs. So I will do that. I know that I'm not breaking anything, but just keep in mind that you might break some connections to some devices in your computer, but shouldn't be the case. Okay, changing to COM4. Okay. Now this USB to serial port thing is COM4, so my new JTAG is COM4. Let's click on COM4 and connect. Now it is blinking, and I'm getting this message here, which is the proof that the JTAG is alive. It's basically saying, hey, we do have a JTAG, but we don't have a target. The target is the MCU in your game console. So it is done. We're done. It is alive.